All right, last time we discussed 1D motion for constant acceleration that's moving in a horizontal um, position. And today we'll cover 1D freefall. So as we discussed last time, you can really transform the 1D constant acceleration into 1D freefall. And there are 5 equations for this as well. So this is for objects that are either falling down or objects that have been thrown upward and then ultimately they fall down. So objects fall back to the ground because of the gravitational force between the earth and the object. And the acceleration experienced by the object due to the Earth's attraction is approximately 10 meters per second square. And there's a convention here, so this is g 10 meters per second square. And if it is moving upward, here the designation is it's in a positive value of 10 meters per second square, but falling down is negative. But as you know, objects that have been thrown upward will ultimately come down. So your teachers and textbooks will end up using mostly minus 10 meters per second square. But you could use either of these. As long as you set up the problem properly, you should be able to use these equations. So on this one, this problem is talking about you're on top of a building and you drop a bowling ball and it hits the ground. Um, you know, there's a ball, you drop it from here, and then it's falling, so that means its initial velocity is 0, and then it hits the ground within 4 seconds. So um so we know that this is the initial height because it started with some height above the ground. We can note this as y naught, and the height that's changing as a function of time is what we call yt, right? So now going up here, we can use this second equation. Yt equals, this is yt minus y naught equals v initial t plus 1 half gt squared. So here we are asked to find for part A what's the height of the building. And what we know is that at the time this ball touched the ground, which is yt, is 0 because it touched the ground. That's our reference, right? So that means y of 4 is 0. So here we're looking for y of 4 minus y0, y0 equals initial velocity is 0 because it's a free fall, 1 half negative 10 times 4 squared, right? So this is y of 4 is 0, 0 minus y naught equals negative 5 times 16. And you have negative y naught equals negative 80, which means y naught is 80 meters. So it's thrown down from 80 meters. And then the next question is asking you what's the speed of the falling ball as it hits the ground, right? So for this one, I want to show you like one method. So imagine like you're not given time and yt minus y naught equals v naught t plus 1 half gt squared, right? And here yt minus, from previous problem we found it's 80, insert there, and then initial velocity is 0, so this gives you 1 half gt squared. And so yt minus 80 minus 5t squared. And if you move this to the other side, you have an equation that's written as a function of time. So from your calculus class, you will learn that a derivative of position gives you velocity, which means velocity is dy dt. And if you take the derivative of 80 minus 5t squared, this gives you, so constant 80 becomes 0 minus 10t. So, velocity is expressed as a function of time like this. So v of t is actually negative 10t. So now you just replace t of 4 seconds, that gives you 4 times 10 becomes negative 40 meter per second, right? And then the other one is how far has the object fallen just 2 seconds, just within 2 seconds. So sorry, let me label this. This is B. We solved A, and then the next one is C. So for this one, again, the beauty of expressing this as a function of time, which is yt equals 80 minus 5t squared, just allows you to be able to solve position and velocity at any point in time. So now you're looking for here the position at t equals 2. So that means 80 minus 5 times 2 squared. So this is 80 minus 5 times 4 is 20, so 60. So it's 60 meters above the ground. That means it has fallen 20 meters below, right? And then the next one is D. What's the speed of the falling ball after just 2 seconds? And really here, just the beauty, again, expressing it as a function of time, we know that Vt as a function of time is, 10t, negative 10t. So Vt equals 2 becomes negative 10 times 2. So you have negative 20 meter per second, right? And let's go to E. E is asking for how much time does it take for the ball to fall halfway down the side of the building. And this is also amazing because now we know the expression for yt as a function of time, at 5t squared. And this is asking us, it's half the height, that means it's 40. So we just do 40 equals 80 minus 5t squared. And you do 40 minus 80 equals minus 5t squared. This gives you negative 40 equals negative 5t squared. And here you get t squared equals 8. So t becomes a square root of 8. So you can answer all of these questions, and all you need to do is try to express this as a function of time, and you just need to insert the time component in order to find, what position or velocity you need to get.